Tarien Jacobs from the Northwest University Potchefstroom campus, who will then present to us on an analytical method to quantify the metabolites and cofactors of the methionine-homocysteine cycle. So if you can kindly just stop your share. Tarien Jacobs, you can then go ahead.
Okay, hello everyone. Can you hear me? I'll share my PowerPoint now. Just want
yes, we can hear and see you. Yeah.
Okay, then you. I'm just going to stop my video. I hope this is clear to you all and that you all can see my PowerPoint.
Yes, we can. Thank you.
Okay, thank you. So yeah, good day everyone. My name is Tarien Jacobs and I'm a master's student at the Northwest University of Potchefstroom. And today I will be doing a presentation about my master's study, that is titled an analytical method to quantify the metabolites and cofactors of the methionine-homocysteine cycle to monitor the methylation process in hormone users. My supervisors are Prof. Lourdes Erasmus and Dr. Gerda Venter. Okay, so biotransformation protects the body from endobiotic and xenobiotic substances. Natural endogenous and synthetic exogenous hormones are examples of such substances. Estrogen is the primary sex hormone in women and is produced from cholesterol in the ovaries. Synthetic forms of these hormones are often included in hormonal products such as combined oral contraceptives. During biotransformation, these compounds are transformed to water-soluble compounds to facilitate excretion. Endogenous and exogenous estrogens can undergo sulfation and glucuronidation, and it can also undergo hydroxylation. Estrogens can be hydroxylated to form catechol estrogens with the help of different cytochrome P450 isoforms. These catechol estrogens are defined as carcinogenic because they lead to the formation of kinome DNA adducts that may induce DNA damage. The inactivation of these catechol estrogens to prevent the DNA adduct formation is therefore of great importance. Methylation is the most active catechol estrogen detoxification pathway. The process of methylation leads to the formation of methoxyestrogens that can be easily excreted. The enzyme catechol-O-methyltransferase, or COMT, is responsible for the methylation of the catechol estrogens, and it also transfers a methyl group from S-adenosyl methionine, or SAM, to the hydroxyl group of the catechol estrogen. So various factors can disturb this methylation process and thus estrogen biotransformation homeostasis. Polymorphisms in the gene that encodes for the enzyme COMT may lead to a variation in enzyme activity. And some polymorphisms might cause the COMT activity to decrease, leading to a possible increase in estrogen kinome and depurinating DNA adduct formation. And this subsequently increases the risk of tumor formation. Because SAM donates a methyl group to COMT during methylation, insufficient COMT activity and ineffective methylation might influence SAM levels and other metabolites of the methionine-homocysteine cycle. The importance of estrogen methylation is demonstrated by the fact that women with a polymorphism in the COMT pathway, which negatively affect the rate of methylation, are more prone to develop breast cancer. The regulation of SAM and COMT is therefore critical and crucial to ensure that this biotransformation process proceeds as needed. So the SAM that is needed for the methylation of catechol estrogens is generated in the methionine-homocysteine cycle. During this cycle, the amino acid methionine is converted to SAM. After SAM donates its methyl group, the metabolite S-adenosyl homocysteine is formed. During an enzymatic reaction, SAH is converted to homocysteine. This amino acid can then be subjected to transsulfuration or remethylation. During transsulfuration, homocysteine reacts with serine, enzymes, and other cofactors such as vitamin B6 to produce cysteine. During remethylation, homocysteine is converted back to methionine, and this is a vitamin B12 dependent reaction. And during this process, a methyl group is donated by the folate cycle, which is closely linked to the methionine-homocysteine cycle. Oh, sorry. As you can see, there is a large amount of metabolites and cofactors in this cycle, and the regulation of all of these metabolites and cofactors are critical to ensure the effectiveness of this cycle. At the Biotransformation and Oxidative Stress Laboratory of the Northwest University, the urinary hormone metabolite profile of clinically referred patients is routinely analyzed, and problems with the methylation metabolism is reflected by low levels of the methoxy estrogens, as can be seen here, and increased levels of the glutathione conjugates and DNA adducts. After they have been treated with a cofactor cocktail that promotes the detoxification of catechol estrogens and the kinones, these profiles change, showing a better methylation and less methylation and less adduct formation. So the methionine-homocysteine cycle is tightly coupled to the biotransformation of estrogen, and disturbances in the levels of the metabolites and cofactors involved in this cycle can affect estrogen methylation. To identify the affected pathways and design appropriate treatment strategies, comprehensive analysis of the metabolites and cofactors of the methionine-homocysteine cycle is required. However, we do not have an in-house analytical method to comprehensively quantify the metabolites and cofactors of the methionine-homocysteine cycle in serum samples. Therefore, the aim of this study is to develop a targeted liquid chromatography electrospray ionization tandem mass spectrometry method to quantify the metabolites and cofactors of the methionine-homocysteine cycle to investigate the effect of combined oral contraceptives on the methylation process. To achieve the aim, the following objectives are important. Firstly, the implementation and optimization of a LC-ESI-MS-MS method. Secondly, the validation of the developed method. And lastly, the developed and the validated method will be applied to combined oral contraceptive users and a control group to investigate how the methylation cycle is influenced by hormone use. During my study, I implemented the method developed by Gerard et al. This group of researchers developed a LC-ESI-MS-MS method to quantify metabolites and cofactors of the methionine-homocysteine cycle using a trifunctional C18 column and ion pairing agents. because of the difference in the instrumentation I am using, I had to optimize the ionization and source conditions for each metabolite of interest to me. As I mentioned, Gerard made use of an ion pairing agent. So the ion pairing agent, having a nonpolar end, binds to the nonpolar stationary phase, and this makes this stationary phase more hydrophilic and causes a better retention of the polar compounds. During the implementation of this method, it was clear that the easy sample preparation and short runtime makes this method alluring. However, it is known that the use of ion pairing agents causes the suppression of ionization. This is a chromatographic profile of the metabolites and cofactors of interest to me, including the metabolites and cofactors that Gerard looked at. I am also expanding the methylation profile to include homocysteine, cysteine, and glutathione, as these are also important to get a more comprehensive picture of the methylation cycle. So here it is clear that there is not sufficient, that there might not be sufficient ionization. And in this chromatogram, I scaled the chromatogram to show a more comprehensive visual of chromatographic separation. I also find that the retention obtained was not completely successful, and the chromatographic separation was not completely successful. So, and it can use some improvement. To improve this, I adjusted the gradient of the mobile phases used by them. And during this adjustment of the gradient, I managed to obtain chromatographic separation between choline and methionine. This is before I changed the gradient, and this was after. But I also found that glycine, cysteine, betaine, and dimethylglycine co-eluted, and I couldn't.
Can I just, sorry. Can I just ask that all participants please mute their mics?
And I couldn't, with the adjustment of the gradient, I couldn't obtain better chromatographic separation. This is only profiles of 2 different gradients. I used others as well, but did not find it to be successful. So the next chromatogram is an unscaled chromatogram of all the metabolites and cofactors. Here it is clear that the sensitivity is lacking, and yeah, I'm also struggling with response. And when analyzing the compounds in a matrix, low abundances and of the metabolites of interest were also detected. So achieving better retention of the polar compounds on the C18 column will increase the selectivity, the sensitivity, and the efficiency of this method. And a possible solution for the problems I'm facing is the use of derivatization, and more specifically methylation. So during this process of derivatization, the polarity of the compound changes, causing better retention. Yeah, that means that there would be better retention on a C18 column. The sensitivity and the selectivity, together with the response and the ionization, will be increased with the use thereof. So in conclusion, as you can see, I still have some work to do, but I successfully implemented the method by that was developed by Gerard, and I expanded the profile. I'm experiencing a lack of retention, sensitivity, a response, and some problems with ionization, and I hope that the use of derivatization and more specifically methylation can help with these problems. The successful development and validation of a targeted method can help us better understand the improvement we see in the methylation of catechol estrogens and help us understand if combined oral contraceptives have influence on the effectiveness of the methylation cycle. Thank you.
Thank you so much for that, Tarien. Are there any questions for her? I'm just going to check if there's any hands raised. Okay, I don't see any hands raised, and I don't see anything in the chat. Which year are you currently? Is it your first year in your MSc or your second year?
It's my second year.
Okay. Dr. Shane Mason says, great presentation, Tarien.
Thank you, Doctor.
There are no questions. Thank you very much for your time and for sharing your data with us. Feel free to post your email address if anybody maybe perhaps has suggestions for you on how to work through those problems that you are experiencing, then they can perhaps reach out and assist you in that regard. Thank you so much.
Thank you so much.